Okay, this is starting the new stream. My last stream shut down, I'm not sure why. Um, let's just make sure that this pops up first, and we're good to go. Okay. I might just be having, do I have slow internet? It says excellent connection. I'm not sure if this stream stops working, then I'm going to give up and stop trying to stream this. Uh, where? Oh, analytics. Oh yeah, and stream health. Okay, it says we're good. All right, get that back. Oh man, too bad that stream stopped working. So I'm in the middle of trying to get the test optimization to work with the plotting for the new variables. Oh, but it's not gonna work. Not gonna work because we're still using two columns. So the subplots gets yeah, I'm not sure how to make it look nice. We might have to just do ugly plots to start with. Um, damn it. Okay. Let's go look up matplotlib subplots examples. Um, so we want two stacked on the left side and then just a single column on the right side. Controlling view limits using, don't care about view limits, but I do want to make this plot. Yeah, we're gonna have to do plt.subplot. Damn it. plt.subplot 212. So the first one is 212 and it's called zoomed out. No, the first one is 212, it has no title. So 2 rows, 1 column, item 2. Okay, so that should be pretty easy. Well, not pretty easy, but oh, okay. Stream bitrate is low. I don't know what to do about that. Stream bitrate is lower than recommended. Well, I'm paying $130 for internet, so I hope it's moving fast enough. All right, so let's go back here. We have to basically do it this way, manually add subplots, not automatically generate them. Perform optimizations. All right. So num subplots. Okay, so we're gonna say for param in best params dot keys. For param in best params dot keys, we're gonna say plt dot add plt dot subplot. And so we always want to do, can we do commas for that subplot? Let's go check. So Python 3 from matplotlib import pyplot as plt, plt.subplot. Cool. So we can do commas. Now, if plot equals true, so for param in best params of keys, num rows will always be so for each param, number of rows will just be the length of however many params there are. And then num calls is equal to, so there's a certain number of rows, a certain number of columns. plt.subplot, and you just specify row column. So how many rows, how many columns? So that would be 2 rows. This would be 2 rows, 1 column, and it would be the second subplot. This would be 2 rows, 2 columns, and the first subplot. This would be 2 rows, 2 columns, and the second subplot. So we're going to say, now there's 2 columns. So for plt.subplot, so I keep forgetting, so it's number of rows, then number of columns. So number of rows, number of columns, and then whatever the index should be. So for the first one, let's open up Notepad and mess around with it a little bit. So all right, so if we're dealing with the first parameter, then the index should be 1. Now, if we're dealing with the second parameter, the index should be 1, 2, 3. If we're dealing with the third parameter, it should be 1, 2, 3, 4, 5. Okay, so it's just, we could do parameter minus 1. Oh, just parameter times 2 minus 1. So whatever parameter number is times 2 minus 1. And then here, it would be for C, param in best params in enumerate best params dot keys, plt.subplot, and then the subplot number, and then the indexing starts at 0, so it should be C plus 1. That whole thing times 2, and then just subtract 1. Okay, and then we get that, and then let's just comment all this out because we might need it until we know that the new version works. Okay, then analysis.plot region, plt.subplot, so axis is equal to that, and then we're gonna do this. Okay, then analysis.separate data, and then we're gonna say that the results axis is equal to, My dogs are barking. I'm gonna have to go get them to stop. Um, so where were we? So now we're gonna want to add the subplot for the results. We're gonna say that there's one row, two columns, and this is the second item in there. And then pass through to here, results axis. All right, now let's see how that looks. Hoping that it looks good, but we'll have to see. We could update our Trello board while we're waiting. Damn it. In differential evolution, one of the lower bounds is greater than an upper bound. One of the lower bounds is greater than an upper bound. So minus 40, oh. Okay, this is an upper bound. So this should be minus 1,000 to minus 50.1. So that wasn't even the problem we were having. We're having a different problem. Okay. Now back to the Trello board. Analytics. Okay. So, okay, now we want to change output to be in terms of percent return. This finished, I think. Let's go look at the new plot. Nice. And now we're just going to want to make that bigger. So the best values for A was when it was really low. The best values for B was when it was slightly above 0. It's got the parameters backwards. Both are going from minus 1,000 to 0. What? We also want to do tight layout. So that it looks nicer. Now, yeah, why are A and B varying the same amount? A and B, why are they varying the same amount? So A should go from minus 49.9 to 300. B should go from minus 1,000 to minus 50.1. With open metadata file, A plus is F. For C param, line string. Join region params of I. Join it with okay, so get the region parameters, add a comma at the end, and then join it. And then add the profit string at the end. So let's go see what the parameters look like. A, B, profit. Okay, A looks good, and it just got stuck at minus 19. Oh, the profit's on the y-axis. Um, okay, so I guess we want to change the bounds a little bit. It's looking for way too high values for A, so instead of 300 for A, let's change it to 50 or 100. Um, let's go see. Let's look at that plot again. Yeah, I think 100 should be okay. And B, the profit basically switches for B depending if A gets really high. All right. Now, don't want to save that. Um, okay, and then B goes down to minus 1,000. So B should probably go lower. Let's send B down to minus 1,500. Okay, let's run that, and I gotta run to the bathroom real quick. Okay, so it's been going for a while. It might have some trouble converging on an answer. Nope, there we go. See what the plot looks like. Hopefully it'll be nicer. Nice, got that tight layout. I mean, still didn't fit everything in though. Nice for A though, there's a pretty clear pattern. For B, seems like B doesn't really affect much. A affects a lot. So where does A optimize? I would expect A to optimize to about that line we were looking at. Um, Now, trying to figure out what to do with B because it doesn't seem like B is doing very much. B, I mean, for all values of B, profit's kind of all over the place. For that really negative value of B, we got low profit. Um, A seems more important that we have to keep it before that cutoff. Or actually, it seems like A could be optimized to get that point right there. So maybe around minus 20 something. What does A optimize to? I guess if A optimizes to minus 22.2, that could be evidence that the line we're using is right. Okay, so A gets pretty close to that value of minus 22.2. B finds minus 200. Which isn't very interesting. B, it doesn't seem like it's finding much of a value at all. Let's go in and plot this in Excel. So I just want to get a better idea of what the data looks like. So Excel. All right, so how does A change over time? What? Let's just delete this. A, what? A, B, profit. Huh. I guess I imported the text wrong. Okay, so you could see A clearly converges. B seems to converge. We don't need the really low values of B, so we could change B to be minus 600. Change A to be 40 maybe. Whoa. Minus 600. And that goes up to 40. Finally, profit should hone in on a positive value. Nice. Oh, and once we got that B honed in, we got a nice little jump in profit. So B does matter for profit. But let's see, we might get a better optimization if we use these updated parameters. Okay, let's go back to the Trello board so we can update what we're up to. Now I want to test new region. All right. Now let's see what this did. Okay. So we're still getting that B where I mean, we would like to slice that data off, but that's fine. That's interesting that B ends up there. It could go lower and it's not like it would take on a lot of losses. That should be easier if we just open the CSV in Excel. All right, now A looks like that. B looks like that. Oh, nice. So B still converged to about the same value. A converged to about the same value. And profit also converged to about 200. Okay. Now let's try increasing the population size. We're using 5. Let's try something bigger and see if we're able to bump up that profit amount at all. Okay. So minimize that. Minimize that. Back to the Trello board, test new region, and what the region should look like. Oops. Minus 20 line. And it's about there. Fixed. And then vertical line with variable x int, and then so y equals minus x minus 20 line is fixed. Then there's a vertical line with variable x int, and then there's a y equals minus x plus b line that moves up and down to with, okay, that moves up and down. The hope is that this line with free parameter b should cut out problematic data. So we want it to cut out the problematic data that we observed right here. So this stuff, basically as we're using the triangle technique, we have this constant line that's just below the blue line here that cuts out all the data above it. And then we have this triangle that moves up and down along here, sorry, a vertical line that moves up and down along here to get the triangle strategy. The problem is that the triangle basically optimizes to this point right here, and it's cutting off this data. I think that we could use this lower line and then get the triangle more up here somewhere if we had a second line to cut this off. And then furthermore, the only free parameters in the equation I just wrote are b, the parameter for where the second line goes, and then the parameter for where the vertical line goes. So it's the same number of free parameters as the current optimizations I'm trying to run. So let's go see how that current optimization did. Lots more data. We ended up with a much finer region. Yep. And then if we go look at that data, convert it. All right, so here's A. Still found that value right around minus 20. See if it's any closer to minus 22.2. No, still minus 19 something. All right, now let's put this in here. See what the profit was. Now the profit didn't even hit 200. That's weird. So when we use a higher population size, we got profit close to 200. So what was the profit? 186. Now what's the profit here? Oh, 151. So substantially less profit with a larger population size. Larger population size found less profit. How does that work? Larger population size should give us a better result. Um, huh. So what if we do B versus profit? Let's say okay. And for the higher B gets, we see there's kind of this behavior down here where it cuts off the profit. Let me see how profit did over time. What did B do over time? Okay, so it got up there to about minus 100. That, I'm pretty sure, is different from the other plots. Here, B got to minus 200. So this did what we wanted. This did what we wanted because it cut out the troublesome region we were talking about, but it um, it didn't do what we wanted in the sense that um, well, in the sense that we're making less money, but it did do what we wanted in terms of cutting out the troublesome region. You can see 239, the most recent one. That's a very narrow region there. 238, the one right before, it's using a much wider region. So this one, it's taking a lot more bets. And it's including this data down here that I said is the troublesome trend. This, we see here, there's this group here and that group there. The data is cut out here. Okay. Now, this is what I'm thinking, because this this basically found it cut out this problematic data. So what I'm thinking is that um, like imagine this data down here wasn't there. Then you could have a vertical line that goes up till right here. It includes all of these green bets in this region that would have been cut out with the other vertical line that optimizes to right there. So I think that will be the next thing I look at. Don't need to save those because we already have the output. Um, is the stream still going? Good. No viewers, but the stream is going. And the stupid thing, stream bit rate, not fast enough. So we have this strategy. Now the next thing to do, okay, so we're gonna go want to build what our new region looks like. Um, to get our new region, we basically need the two variables. So what I'm going to do here, now 25 is a fairly large population size. We could say, make it a little, let's just do 25 because we know it's safe. Uh, we don't want to make the population size larger than it has to be because it will take more time. So, I mean, yeah, let's just make the population size that. We can and then we'll train it. So now let's say test optimization equals true, perform optimization analysis, test training years. So num years for year and num years. Num years, oh, we don't need that. We just need optimization analysis. We want to test num years to train on. So let's do going back 5 years, 7, 8, 9, 10, 11. So the first year we can do is 12. Um, all right, years to test is equal to that. Oops. All right, years to test is equal to this. All right. Then we put in years to test. So if we want to get all of them, np.arange from 2007 to 2022, then you do dot to list. Start in 2008. All right, then perform optimizations. Um, so we also want, yeah, we're gonna want to store this data in a different folder and store metadata for it too. But for now, we could just let that run. Now this will do all years. It trains on data from all previous years. This will take a pretty long time to run. All right. Yeah, we only really, I mean, 17, 18, 19, 20, 21. Num years to train on. Let's just go 5 years back. And let's include 2016. And just to make sure, we're currently on 239 for today. Okay, and then the last thing is we want to turn this on. Don't want to miss any chats. So test optimization now is off. Perform optimization analysis is on. Perform optimization analysis uses the rectangle region type. It'll do train on the previous 5 years. And let's go get them. Okay, now this code is going to take a while to run. Let's start a timer. So we're at 239. Just the first optimization should take a while. Hope that didn't mess things up. Ah, okay. File analysis 1.py. Raise exception, rectangle region must contain the right params. Test years is equal to years to test, num years to train on. Region type file analysis in perform optimizations. Okay, so in perform optimizations, line 314. Okay, so perform optimization. Yeah, so let's go to perform optimizations. Region type. Defaults to triangle, but here we passed in rectangle. Perform optimizations, line 314. Oh, so it's that result thing again. Analysis 1, trend 3. Region params. Print region params. Okay, so that means the region type we passed in. Huh. So we're getting the wrong region params. What? I thought optimize line location worked. Okay. Need to think. Need to think. Need to think. Need to think. Okay, so we want to know where is our problem coming from? The optimization works fine, but somewhere in here it gets messed up. Region type. Okay. So first thing it does is print region type. Okay, so there it's rectangle. Um, my mom is calling. Hi, Mom. Can I call you in a little bit? I'm doing a live stream of coding right now. Okay. So we're back to getting this problem. Optimize line location of training seasons and region type. Region type here is rectangle. So it's not printed over. Yeah, so put the debugger in there. Now let's see what is region type here. Still rectangle, so training seasons. So region type defaults to triangle, but here we specified the region type as the second argument. So it might be taking that as plot and then passing triangle. So we should say region type equals region type. I'm sure that's what's happening. Okay, that's going to quit, and then we'll be able to retry it and run it again. Okay, now we could take out that debugger line. And now it should work correctly. Now let's go figure out what we're going to do next, and we'll keep an eye on that to make sure that it works correctly. Now this would be really cool if we returned a profit on each. The hope is that this line with free parameter b should cut out the problematic data. In summary, this is the same strategy as in summary, this is the same strategy as the triangle strategy, as the triangle region strategy. So it's the same strategy as the triangle region with a line added in the bottom to cut out data, problematic data, noticed in analysis 1, trend 3. Okay, now let's go see for the first optimization, what did it go to? We were on 240. Oh, no, it hasn't finished any of them. So the first one that has a plot should be the most recent. Okay, so now add metadata file for plotting analysis. And so to do that, we're going to have to metadata file for plotting the analysis. Test new region, medium. Oh, that one, I saw the command prompt stop for a bit, so we might have finished on 243. Nice. Let's see what it did. So the very narrow line again. That's interesting. Profit starts climbing back up for A. Am I optimizing for all? Test years. Num years to train on defaults to all. Then, yeah, num years to train on is 5. Perform optimization analysis. Yep. Num years to train on is 5. So why the hell is it training on 10 years? $243 metadata. 11, 12, 13, 14, 15. No, that looks right. When we're plotting, are we plotting it on all data? Plot title. So it's just that we're not changing the training. Separate data, seasons. Plot region. Oh, and then subtitle, optimizing for season for season and seasons. So this is every season? Damn it. All right, so optimize line location, training seasons. Yeah, why is this showing so many seasons? I think we're training on too many seasons. 243 finished 3 minutes ago. Okay, but in the metadata file, it wrote seasons. So in metadata, it wrote seasons. Metadata. So it writes seasons for season and season. So this is right still here. Separate data. Huh. I'm gonna wait for the second one to show up to see if it's plotting the right thing. Oh, nice. There it is. Nice. Okay. Damn it. Okay. So now the plotting's getting messed up, but at least it's right. Um, if plot is equal to true, let's go ahead and clear everything off. Now I'm gonna have to stop this, unfortunately, and go again. Before that, though, where analysis 1, trend 3, test all results. Ah, this is from the last time we ran it. All right. Um, Now we could try to make the plot nice. I mean, whatever. Yeah, sorry. Um, so I'm gonna leave the plot alone for now. Let's run that analysis again. Okay. Now it's running. Now let's figure out what we want to do. Yeah, we want to define the new region, add metadata file. Where do we explain the region we wanted to test? Did I not save that? Oh man, that sucks. Yeah, I guess I didn't save it. Oh, cool. Um, just make it high priority because now that's what I'm working on. And that's actually bottlenecked until region type. So it's bottlenecked until we could do that. If we open it with VS Code, it won't break it. Now, what's the profit at? Profits at 138. Sorry, yeah, profit. So fixed profit to 138, I think. Nice. Um, Now if we go check what that data is looking like right now. Sorry, let's go look at what the plot did. So it still included that second region up here. That must be because it got this data down here. But as A moves higher, then the profit starts to come back. So we want A to go a little higher. Or actually, yeah, we want A to go higher because there might be another good region. There might be like the same and opposite thing up here. Or we can do it for each region. You know, optimize for a below region and get that, then optimize for an above region, get that, and then put them together, take all bets that are in the two joint regions. Um, yeah. So that would be interesting to do is look at this. If we keep increasing A, how do we do? Nice, 247 completed now as well. Oh, that's interesting. 247 found a damn it, much lower value for this one. So 2017 will probably lose because it's including a lot of data. 246. Oh, 246 is including that data too. Maybe it doesn't have enough data to cut that point out. I don't know. But let's go build the new region. So triangle region, rectangle region, and let's define the combined region. I'll just call it hybrid. The hybrid region is combination, sorry, hybrid, yeah, hybrid region type is combination of rectangle and triangle regions. And this is defined by indent that, and let's indent all this stuff. All right, indent that, and indent everything down here. All right, now hybrid is combination of rectangle and triangle, and it's defined by 3 lines. The first line is y equals minus x minus 22.22222222, repeating. The second line is y equals x int. X int is the free parameter. This line is vertical, obviously. And then the third line we're going to define is y is equal to minus x plus b, where b is the free parameter. And then, so point 1 will be defined by intersection of line 1 and line 2. All right. Now point 2 is defined as the intersection of line 2 and line 3. Point 3 is the intersection of line 2 and line 3. Intersection of line 3 extended to x equals 2000. Intersection of line 3 extended to x equals 2000 with line okay, so point 3 is just line 3 extended to x equals 2000. And then point 4 is line 1 extended to x equals 2000. Cool. And then we have a new valid region type. And hybrid. So hybrid, and the parameters for this should be guess X int and B. Okay. So, go back, check the stream again. Still warning me about stream health. Okay. Um, okay, so we have our hybrid method, separate data, get region, region type equals triangle, test region type of region type. Now if region type equals triangle, do this. Otherwise, if region type equals rectangle, do that. No, otherwise, if region type is equal to hybrid, let's pull up our notepad. We want it to look like so if region type's hybrid, we want it to be this. All right. Okay. So line 1 region type equals hybrid. So line 1 equals, so point 1 is intersection of line 1 and line 2. Uh, so line 1 equals y1 equals minus x1 plus minus 22.2 repeating. And then the second line is y2 is equal to x int. And then we want to find out where they intersect. So we want to find where x int is equal to minus x1 minus 22.22222 repeating. Oh yeah, the x-intercept will be the x-intercept, duh. So the intersection of these two lines will be x int, and the y intersection will be wherever x1 is equal to x int. So the y intersection will be minus x int minus 22.2 repeating. All right, so the second point is intersection of line 2 and line 3. So this is point 1. Point 2 is the intersection of line 1 and line 3 would just be x int minus x int plus b. Point 3 is line 3 extended to x equals 2000, so just 2000 is line 3 extended to that. So 2000 and then minus 2000 plus b. And then point 4 is line 1 extended to 2000, so 2000 and then 2000 minus 22.2 repeating. Okay, so that's pretty easy enough. So if region type is equal to hybrid for param in, so this we could actually say for param in valid region types in valid region types of region. And hold everything region type. And elif region type is equal to triangle if xnet int. Okay, so this we can actually take it out and put it up above and say, do this to everything. Make sure params are in there. Okay, then if region type is equal to triangle, could take that thing out. Not so if for param and valid region types of region type, if param not in region params dot keys raise an exception. You could take this out. Or I'm just going to comment it out because I'm afraid we might need it. Valid region type. Oh. So instead of xint, it should be region params of xint. And then minus region params of xint. Okay. And then this is also region params of xint. Okay. Okay, so we've got our points defined. No, we don't. Okay, so elif region type is equal to hybrid point 1 is equal to x region points equals point 1, point 2. Okay, so point 1 is equal to region params of point 1 equals region params of xint, and then minus region params of xint minus 22.2 repeating. All right. Now we have point 2 is equal to xint and then minus xint plus b cool. All right, so we have point 2. Now point 3 is 2000 minus 2000 plus region params of b, and then point 4 minus 2000 plus region params of b, and then point 4 is equal to 2000 minus 2000 plus minus 22.2 repeating. Okay, and then region points is equal to point 1, point 2, point 3, and point 4. Okay. Um, Now we ran the optimization. Let's go see how it performed. Man, so it's still including, it seems to always include that data. It's making B pretty low there and including all of that data. Huh, all right. Um, Now let's go see how it performed. Okay, so positive in 16, negative in 17, negative in 18, negative in 19, but positive for 20 and 21. Well, that's a disappointment. So let's put it in the PowerPoint. Say new slide, rectangular region. Let's go here and turn on just the plotting so we can see what a rectangular region looks like. Um, so we're going to test the region plot. Okay. Now that was with large values for each. So instead of that, we're going to do b equals minus 200, minus 150. All right, run it again. Now this is what we wanted. We just wanted to cut out that data right there. Okay. Okay, so let's go put this in our PowerPoint. We All right, so we're gonna say that, let's put text box in. Now my girlfriend's calling. Can I call you later? Well, no one's watching this anyway. Let's see. Oh, someone is watching it. Thanks for watching. Okay, I'll just text her then. I'm doing live stream. Okay, sounds good. Love you. All right, now let's get back to it. So we wrote code to, where'd it go? We wrote code to add a new region. Added a rectangular region with uses same, no, uses two lines with slope of -1 and variable y-intercepts, and then The purpose of this strategy is to remove problematic data from this trend analysis 1 trend 2. So basically remove that. Problematic data from analysis 1 trend 2. Okay. So now the optimization results. Let's just add a new slide. We'll say optimization results training on previous 5 years. So just put this in here. Here's what our results were. Okay. Then here, let's say, basically the problem is it didn't cut off the problematic data like we intended. So we're going to note that. Didn't cut off problematic data as intended. Okay, then let's put whatever the results were in there. Okay. Oh, forgot I want to put it in the PowerPoint. This should be smaller. Okay. So it doesn't cut out the problematic data like we were hoping it would. At all. Okay, so we could also train on all previous years, but I don't really see a point in that. Okay, so for the new region, we're making a new region. So do we need to change anything else other than, I mean, plot region, test region plot. Okay, let's just go in here now. Test region plot, region params. Now let's rewrite region params for our new equation. It's just x int should be, let's make it 50. And then this other one, b minus 90. Region type, instead of rectangle, is equal to hybrid. Okay. Let's go run that. Nice. So this region basically gives us the ability to cut out this data right here. We want to maximize this while cutting off this. We could also add like a cutout region, put a box around a region that you don't want to bet on. But yeah, that will basically give us the box we want. We could kind of mess around with it manually. Let's make B a little lower, maybe minus 120. And accent should be lower, minus 100. And what's that plot look like? Nice. So that's closer to what we're looking for. And we capture most of these blue points. We also get some red points in there. We would want to avoid those. All right. Now, so we have this. The only thing we really need to change is in here, optimize line location, is where we have bounds. So elif region type is equal to hybrid, then bounds is equal to, so the first value is the x-intercept. That should be able to vary from like minus 500 to positive 500. And then the up-down line, the highest that could be is minus 23. Yeah, minus 23 is the highest it could be. The lowest it could be is minus 250. And that ensures that we won't ever mess up our line. We'll just call this up to minus 22.5. I don't think that'll make much of a difference, but it might. Now we're gonna test the optimization. So here's test region plot. Let's take that off. Now turn test optimization on. And I think that should be working. Save it, and let's go run our file. Okay, I'm going to the bathroom. I'll be right back. And it's still running. It should stop soon. We could go see how it's performing right now. It might have trouble converging on a solution. 252 metadata. Oh, metadata. Metadata. Alright, season, region type. Damn it. Alright. Optimize line location. Test optimization. Region type is not rectangle. Should be hybrid. I thought I changed it. Test region profit. Oh, I changed test region plot. Alright, now this, let's cut that out. And now, let's see how it does. Now we could go back to our data. Check how it's doing. 253. So it is doing the right thing now. It's having trouble converging though. Alright, so here's at 137 evaluations. Now we basically doubled the evaluations. Yeah, we'll just wait for that to finish and add in new regions as necessary. So define new region type. That is done now. Now this is no longer bottlenecked. All right. Change output to be in terms of percent return instead of percentage on constant bets. That would be good, but we probably want to test the percent return first. Man, this is having trouble converging, I think. Weird. Actually, yeah. Oh, we're getting closer. I mean, 153. That's interesting. 190 up here, what did that do? Minus 235 and minus 198. Nice, finally finished. Man, that took forever to run. Now, if we're gonna do this iteratively, we might just not be able to. What's that region look like? Damn it! It's still including all those points? I don't understand why it would include those points. That is weird, man. Okay, so as x int goes higher, the profit basically goes to nothing. And the ideal value is somewhere around here. B, the ideal value is very obvious. Huh. Let's show the... Damn it, I wanted to see that plot. Okay, let's just put this in Excel. Or we could just open it in Excel and look at it. with Excel. All right, so what did the xint do over time? All right, b, what did you do over time? Oh, that's why it took so long, because we're still using a large population size. Profit, what did you do over time? So it maxed out the profit. Okay, let's do B, whatever profit is versus B. Can we zoom in on a chart here? Damn it, how do we zoom in? Let's just do it in Matplotlib. All right, so open Python from Matplotlib, import pyplot as plt. Then we could do data is equal to from just say import pandas as pd. Now a is equal to pd dot read csv, and the file is optimization data slash 2023 underscore 12 underscore 13 slash 253 dot csv. What? Optimization data 2023 12 13 253 comma csv. Duh. Dot csv. All right, now a dot head. All right. So plt dot scatter a dot b a dot profit. So we see that as b gets closer to 0, the profit kind of looks like that. That's the dominant trend. And this big spike is from cutting out that problematic data. So why didn't it get us a value at the top of the B spike? So this is the top of the B spike that got us 200. So it's like right around minus 198 to minus 199. I see. I think I know what the problem is. I think that, so here B is heavily dependent on A. How do we do correlation with pandas? Pandas get correlation of two series. Okay. So get out of here. All right, now a dot xint dot correlation with A dot B, 0.1. No, pretty sure it should be the same both ways. Yep. Now how is xint correlated with profit? Xint is negatively correlated with profit. And B is also negatively correlated with profit. They have the same correlation values, which means that they're roughly equally as important, I think. So if I'm just trying to figure out, so when we look at that plot, there's this big spike in B. So most of the data just says, hey, as B gets higher, then the profit tends to go down slightly. We see as we see it especially in these lines here, especially just look at the top here. And then there's this big spike here. Now, what do we do with the big spike? What does the data for A look like? A dot x int. Then let's show that plot. Same thing. So yeah, so it kind of depends a lot on what A and B both are. But A kind of optimizes for down here. That's what's confusing, is why would it optimize to include this data? It should be optimizing to cut that data out. Okay, so here's another question, is what if we changed technique 1? So what if we changed technique 1? Where is it? So instead of just this triangle, it would still be this triangle, but then we would also have a flat line that's positioned to cut out that data. To cut out that data, we want to train, we want to work on cutting out that data. We could hard code a value in there or not. Okay, so I think why not just try it? So if we go back to the triangle method and add this B line, let's go to plot optimization so that we can test where to put that B line. Alright, so test region plot, I'm going to turn that on and get out of here. Alright, exit and let's run our script. Now we should get plotting, so we want to adjust however we define this line so that it's right above here. So what will that look like? So when it goes through 0, it should be about here. So let's just say 175 will be the bottom cutoff. Now, you end up cutting off all that data, but I mean, who cares? Let's try not plotting all years. Let's just try to plot 2007 and see if we could get the position for the line based off that. Test region plot, training seasons, np.a range 2007 to 2008. So now this should just do 2007 data. What's that look like? Okay, and this region isn't even very apparent. It looks like somewhere around minus 180, we could still guess that. So yeah, let's put the second line will be at minus 180 for the bounding box. Now, point 3, point 1 is that, point 2 minus region params of x int minus 22.2222. Now this becomes minus 20,000 plus, so point 2 is region params of x int, okay, and minus 20,000, but instead of minus 20,000, it should be, okay, region params of x int, comma, and then instead of minus 20,000, should be region params of x int plus region params, so region params of x int. Oh, the dogs are barking again. Hey, dog. All right, so we can redefine the second point. Redefining it here, region params of x int plus region params of b. So this would just be region params of x int minus about 180, we said. And then point 3, okay, minus 20,000 and then minus 20,000. So 20,000 and minus 20,000 plus minus 180. Okay. Actually, this we want to rewrite. Point 3 is equal to 20,000 minus 20,000 minus 180. All right. So point 3 has been overwritten, point 4 has been overwritten. Now let's test plotting this. Plot, 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 plot. Okay, so if test region plot equals true, let's say region type is equal to triangle, region params, region params is equal to, and the region params are x int is x int, 0. All right, now let's go test that, see how it looks. Is that the plot that we're looking for? Hopefully it is. Yes, and it is. Okay. The trouble problematic region falls outside. Um, let's make sure the whole thing looks good. Yep. Does that look good? Oh no, so it's coming down to a single point. Did I make point 3 and 4 the same? Let's see our region definition. Point 3. Aha. Point 4. How does oh no. Oh yeah, how did we get that? So so that should be the same as 0.32. So that should be minus 20,022.2 repeating. Okay, cool. Okay, now this plot should be correct. Plot it one more time. And let's go check to make sure that it doesn't come out to a point. Yep, so that looks just like we want, the box we want. Now we can optimize for that triangle. Down here to our booleans. Okay, so test region plot is equal to 0. Now we want to test optimization. Test optimization. Now region type is equal to triangle. Okay. And make sure the plotting is off and optimization is on. Now let's run it. And let's get ready to go do the full optimization analysis, assuming that this optimization works well. Perform optimization analysis equals true. Okay, we're going to train on the previous 5 years. And we're going to make our pop size. Where is the popular? Oh yeah, pop size, not 25, that's huge. Let's make it 10. Okay, cool. Now let's go see what that most recent optimization looks like. Whoa. Whoa, whoa, whoa. That bounding region is huge. Why is that the bounding region? What's going on? 254. Test optimization is equal to true optimized line location 2007 to 2017. Okay. That's the analysis. So let's turn the plotting back on. Perform optimization analysis. Put the plotting back on. Now let's see. Is this plotting the right line? Yeah, that cuts off the problematic data. There's just, I mean, 444, yeah. Yeah, that's, that, I mean, that y-intercept is below 500. X int. So the only thing we're varying with the triangle is x int. Now, get region if region type is equal to triangle. region points, polygon of region points. So if it's triangle, point 1 is the x value of point 1 should be that. Then the y value is wherever the constant line intersects it. Okay, then the next thing we want to do is point 2 is region params of x int minus 20,000. Now that's not what we want. Yeah, right. We want this one. Region params of x int is the y. Okay, then we want the intersection with our other line. So that's just where y equals minus x minus 180. So minus x minus 180. That could be the problem. Alright, point 2 is minus region params of x int minus 180. That's right. Now point 3, you're going to put 20,000 in for x, so that's right. Then point 4, I mean, what the hell is the problem? That's the only thing I could think of. This should be minus, and it was doing plus instead. And if x int is really negative, then that could be what's happening. So what's x int? Oh, yeah. No, not negative there. That's not the one we're looking at. So is x int fairly negative? Not that negative, but I mean, I don't get what's going on here. But anyway, that was the wrong thing. So let's try plotting back to the plot. Plot. Alright, so test region plot. Now, the value we're passing in for x int is 0. So, let's pass in minus 10, minus 100. So it should intercept that at minus 100. Now, let's take off the optimization. Oh yeah, the test region plot's still on. So let's exit out of this plot. Go plot that again. All right. Now what's our x-intercept? Test region plot, x-intercept should be minus 100. Yep, minus 100. Cool. Now what's our y-intercept? Oops. I guess we want y-intercept on this line. So when this line equals 0, probably around minus 200 or something. Let's see, try to draw it again. Yeah, so that's right at minus 180. Now what if we change this to be 300? Is the other line still in the right place? Oh man, that's gonna be hard. It kind of looks like it, but so let's make it minus 300, see what happens. Now the x int will be the same, but the question is what's the y-intercept on this bottom line. Nice, so minus 180, so that y-intercept holds true. Now, let's say optimize line location. Okay, so let's turn on perform optimization analysis. Region type, perform, yeah, we want to test optimization first. Region type is triangle. Want to optimize line location for all years from 2007 through 2017. Let's see how that does. Forgot to turn off plotting and turn optimization on. Okay, now let's go test it. Okay, so that finished. Wonder what these values are it's printing out at the end. Oh yeah, that's how the profit changed. All right, now let's go look at it. Nice. So that gives us the right plot. Now we can optimize, and let's go do that change where we're making it percent change. So perform optimization analysis. Da, 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 da. Now we're getting all years, and we're going to do it on triangle. Optimize on all available years. All right, now let's run that. That's going to take a little bit to run. And while that runs, we can go and change our assessment to be in terms of what happened here. Do we just do the optimization? Yeah. So test optimization is off. Perform optimization analysis is on. And let's go run that. Okay. Now, what do we want to do? We want it to give returns. So assess region should give returns and not profit. Now, returns. Do you add up returns? How to sum returns? Calculating cumulative returns. Holding an asset from time t minus 1 to t, the value of the asset changes. Assuming that no dividends are paid, the 1 period simple return equals so how much it's worth now minus how much it was worth. So the change in value. And then p sub t minus 1 is whatever the previous price was. Okay, so some percent returns for betting. Or we could just say, let's just look at this in Excel. So exit out of that. Don't save it. All right, now open Excel back up. And then how do we look at returns? How do we sum up our returns? So bet amount, result, odds, result, and then return is equal to, so let's make this 10, odds, let's just make that 330, result equals win, and return equals if this is equal to win, then we want to return so we want to return if odds are greater than 0. So if the odds are positive, we should do that, whatever we're betting, times, we should do whatever we're betting times, damn it, whatever the odds are. I hate how they don't let you close these stupid parentheses. All right, whatever we're betting times whatever the odds are, divided by 100. Now the other thing would be if the odds are negative, it should be whatever the bet amount is times, shit, times, and then if it's minus 400, we need to bet $400 to win $1. So if we bet $10, so we need to bet $4 to win $1. What did I say here? How to do the odds? So if odds are greater than 1 plus 100, where should, oh yeah, probability equals 100 divided by odds plus 100. So instead we should do odds minus 100 divided by 100. Damn it. So if the odds are negative, minus 400, pretty sure minus 400 on a $10 bet would return 2.5. So 10 and then minus 400 wins 250. So you do the absolute value of 100 divided by that. Okay. Then we do minus, so the bet amount times minus odds divided by 100. Minus odds divided by 100, is that it? Minus odds divided by minus 100 divided by odds. Minus 100 divided by B2. So that's if, okay, so that gets the odds. Now, if C2 is win, then figure out what to return according to the odds. If C2 is loss, then it's just negative, whatever we bet. I don't know what the hell that means. So, all right, now let's bet another $10 on minus 200. It was a win. Let's fill this down. All right, minus 200 was a win. This should be, we don't care if the formatting looks nice. And then we're gonna do bet this, and the odds would be 372, and the result is a loss. Okay, then percent return is just that divided by whatever we bet. Now, total cumulative returns. So we bet a total of $30. Let's insert a column here. Total returns equals sum from A money 2 to A2. Total return is A money 2 to A2. No, not A. It should be column D. All right, D money 2 to D2. And cumulative returns, percent return, total risk, total risk is equal to sum from A money 1 to A1. All right. And sum from A money, oh, not 1, we want 2. All right. Okay, so percent return, total risk, cumulative returns. So we'll just call this CR1. So for cumulative returns, method 1, and then CR2 for cumulative returns, method 2. And this we're just going to say equals the sum of E money 2 to E2. And CR2 is equal to whatever the total return is divided by the total risk. And let's fill these guys down. Does that yield the right amount? No. So simply adding, so a loss, total return, total risk, percent return is -1. So that's not right. We might have to multiply. Sum product of E money 2 to E2. No, that's wrong too. So whatever the cumulative, so we could get cumulative returns by just summing the total. So let's just assess. So for assess region, we just should sum the total. So for item in region wins, now risk is equal to bet amount times the length of region wins, and then plus bet amount times the length of the region losses, and then percent return is equal to profit divided by risk. So now we've got it to optimize percent. It's optimizing for percent returns instead of profit. So it should maximize our percentage returns over all of the bets. Now, percent return equals profit divided by risk. And we want to return, instead of profit, we want to return percent return. Okay, now let's go look at how our analysis performed. Okay, so those optimizations are finished. Analysis 1, trend 3, test all results. What the hell happened? Oh, okay. Convert, and this strategy doesn't only return positive. Does not only return positive. So let's go look at 2021. Or let's go look at 2020. That will be the second to last optimization that ran. And it ends up including a lot of data. And I bet that's because we're using profit instead of percent returns. So now that we're doing percent returns instead, let's try to optimize it again. Whoa. Percent return equals profit divided by risk. Now, percent return equals profit divided by risk if risk is not equal to 0. Else, make it 0. Now, if we don't take any bets in that region, do we want to return -1 instead? Maybe. I don't know. Now let's go test this again. I want the test to run quicker. Test training years if perform optimization analysis is equal to true. Yeah, we may as well. So let's run the test here. So now we're optimizing for percent returns instead of total profit. We don't care about total profit anymore. But it's still, that key is still profit, but. All right, so 274 is the most recent one, written at 511. 273 was also written at 511. I mean, all right, 275, let's go look at it. Ah, so for nice. Now this is what I was hoping to see. Now this says when we're optimizing, when we're trying to get year 2011, that's great. Optimizing percent returns, now instead of taking any losses, we're not taking a single one. Hell yeah. $276. Oh, so that's interesting. It learned a very different strategy for 2012 than it did for 2011, meaning that this might not return, this might not be reliable. Okay, found the same thing to do for 2013. 2014, same strategy. That might not be good. 2015, went back to the first strategy. 2016, second strategy. 2017, first strategy. 2018, first strategy. Cool. So now we have to try that on our other ones. Exit out of there. Exit out of this stuff. Change output. So finish that. Add metadata file for plotting analysis. That is medium level priority now. Put it over here. Fix plotting. Still need to do that. Okay. And then what are the results? Man, I gotta stop making the default be this. Oh, nice. So that's interesting. When it's learning on not much data, it takes the conservative strategy. And when it's learning on more data, it takes a more aggressive approach. Now that's just for the triangle. That's just for the triangle. So what if we do hybrid down here? Hybrid uses two params and it allows the second one to be free. That's one thing we could do, but then also I mean, one interesting thing would be to say, let's just draw a random box and optimize for that. So we've tested the new region. Okay. Now let's open this one more time. And let's document what we did here. Okay, so that's rectangular. Now modified triangle includes second line at bottom that is fixed to cut out problematic data from analysis 1, trend 2. And the results training on all previous years for results on training from all previous years is this. Okay. And this has been updated so that we get percent return instead of profit. Make this smaller. Okay. So that's what we have. Now we want to build okay, then add in random box region to optimize for. So this just says here's a random box. Now go get points in this random box region and maximize for percent returns. Okay. That is high priority. Now let's go fix the plots just real quick. Matplotlib, specify plot dimensions. F equals plt.figure. So we're not using a figure, plt.figure. Display, plt.plot, plt.figure, fig size. Okay, so let's add that into the plotting that we get here. Plt.figure fig size is equal to sequence. So 2, 2 obviously gives a square figure. I'm gonna assume it's just width height. So width should be, so let's just make it 4 by 2. Twice as wide as it is high. Oops. Exit out of that. Then let's take off the optimization analysis and turn on test optimization. And let's make the pop size smaller. Differential evolution. Pop size is equal to 5, just so it runs fast. Run it again, or run the script. And let's see the figure that this outputs. Spread history data, optimization data. Today, 287. Damn it. Um, all right, now plt.figure f dot. Okay, so we could set the width and height. So, oh damn it. Okay, so fig equals plt.figure. Figure. Fig size is equal to so let's say width height, so 4, 2. Um, yeah, it's hard to tell. So num subplots, so fig add subplot. Cool. And then that's all good. Now results axis equals fig dot subplot. And then fig dot subtitle. Make it a tight layout. Get rid of that. Fig dot save fig. If show plot equals true, show the figure. All right, now let's plot it again, or let's run it again. Should do the optimization and then plot the results from it. Figure has no attribute subplot. Fig dot add subplot. All right, run it again. See if it works. Cool. Now this, uh-oh, did my stream stop working again? Nope, still good. Just get that stupid warning. Okay, I just ran it. Now 289. Cool. That is a big mess. So let's make fig size bigger. 4, 2, let's make it 10 by 6. 10 wide, 6 high. All right, and pop size doesn't matter at all, so it should be 1. Run it again. Now it should be super quick because pop size is so small. Maybe not. Maybe it's having trouble converging. There we go. All right, 290. Ooh, that looks nice. No. I don't even know if there's anything left to change. That looks really good. Cool. All right, let's just make sure that looks nice for when we have multiple parameters. So if test optimization is equal to true, region type is equal to rectangle. Hybrid. Okay, and let's try to optimize that. Then let's go look at the plot. Hopefully it should look good. If it's good, that'll be the end of this stream. Nice. Looks great. Okay, back to the Trello board. Fixed plotting. Now add in random box to optimize for this is bottleneck because it's taking forever. We're just gonna say bottlenecked until we can decide on an analysis method for getting bets to place. Okay, save that. And so we want to add in the random box on the next stream. Is there anything else we want to do next stream? And perform analysis. And then we'll just make a checklist for this real quick. Okay, first item will be to write random box as additional region type. And then optimize, I guess just do analysis on it. Okay, then we're going to say we want to repeat here, we want to repeat analysis on all region types using total percent return as the value to optimize for instead of profit as we were using previously. And that's the highest priority. Let's make another one called critical. That's bright orange. Cool. All right. So that's it for today's live stream. Thanks for watching. We made a fair amount of progress, and I'm hoping on the next live stream we'll be able to continue refining and tuning this model. And then hopefully we'll be able to get our first strategy done. So thanks for watching. Have a nice rest of your day.